here tonight to demonstrate three things. First, the environment-controller-kata. I've seen it demonstrated by Robert Martin. It's basically a thermostat that we're going to be coding tonight. Secondly, we're going to be demonstrating TCR, which is short for test and commit or revert. It's a programming workflow by Beck that combines source control with testing. And thirdly, we're going to be testing with functional options, which is a new approach to testing that I've come up with in the last week or so that I think is pretty interesting. I've chosen these three orthogonal concepts because I'm hoping that at least one of them will be new to you and that you'll maybe glean something from this. So the environment controller kata is a great exercise when you've got someone that's learning about the dependency inversion principle, and it's just a really good reinforcer of depending upon an interface, an abstraction, not a low-level detail. Some specifics on TCR, or test and commit or revert. Basically, whenever we run a test, if the test passes, we will commit the state of the source code. If the tests fail, we will revert to the previously passing test. So this forces us to go in very small steps, and contrary to what you might think, it's actually really great for beginners, I think, because it forces them to take very small steps and keep the tests passing. TCR is a workflow by Beck, by the way. He's also the same guy who came up with TDD, test-driven development. Finally, testing with functional options. This is all about my journey in experimenting with testing. For a long time, well, there are two camps in the Go testing world. There are those that only want you to use the standard library testing package, and there are those who definitely by default just reach for a testing library for convenience. I'm in the second camp, but I'm trying to experiment with ways to get away from that and just use the standard library. And what does that feel like? And using functional options, a pattern discussed by Dave Cheney as well as Russ Cox, or excuse me, I think it's Rob Pike. It's an interesting way to create your own little DSL or API for writing your test suite. Okay, and this approach, because it's so strange and different, is most likely to just annoy both camps, but it's a fun exercise. All right, before we begin, let me just show you what we've got here. It's a simple repository. We've only got one commit, which served to add all of these little files in. All we really have is a make file, which is going to be invoked in order to run our tests. And if they pass, the TCR tool that I'm using will commit the files, and you'll see the commits happen over here. We have a little README. This will all be on GitHub, and you'll be able to inspect the code that we write tonight. Here is the specification for the exercise that we'll be doing. Basically, this is a thermostat that we'll be implementing. We'll write code that could maybe be used to power some HVAC equipment. So let's pretend we've been tasked with writing software for a thermostat that will control HVAC hardware, a heater, a blower, an air conditioner. This hardware must be operated according to the manufacturer's specifications in order to run safely and effectively. To effectively regulate the environment, the temperature should never deviate more than 5 degrees from 70 degrees Fahrenheit. And I think rather than read each of these, you can pause the video and inspect them. We don't have the hardware devices or the drivers yet, but we do have the documentation, and this is the interface against which we will be coding. These are the rules specified by the manufacturer that will keep the equipment running smoothly and according to specification. There are some design questions we have to grapple with early on. How are we going to test drive our thermostat code given that we don't have the actual drivers or the hardware? And there's an element of the passage of time in these requirements. For instance, you have to wait 5 minutes before you turn the blower off after heating. How are we going to mark that passage of time and still write tests that are deterministic? Those are questions we will have to answer. And here's a basic to-do list. I don't think we'll be coming back to this, but you can have this open in another window while you watch this and see how we do as far as our progress. Okay, so we don't have any code yet. Actually, before we get started, let me just remember to start up a little tool. Okay, this is just going to tell us how often we are running our tests. It's kind of an interesting metric to track when we're doing TCR. Okay, so it's been 10 seconds. We haven't run any tests. Let's start off with some sort of file here. Let's just call it controller, since we're building a controller. Oh goodness, and let's make this a little nicer, a little shorter. Okay, and I'm going to just run my test suite here. Okay, so what happened? We have invoked our make file, which ran the tests. There were none, as you can see, but it still passed. Nothing failed, and so we have a single TCR commit, which is the addition of this controller file. As simple as that. Okay, and I think I'd rather have this be a floating window, and we will put it, maybe we'll put it somewhere like, oh, right about there is good, and then this will come there. So we're just going to be able to see that little OK there. Okay, that'll be good enough guide for us. All right, let's choose a test file. And we have run another invocation of TCR. That one took a little longer because I was messing with Windows. Hopefully we won't do that again. Let's just start with a blank test. This is a good way to start. Run TCR. It's only been 19 seconds. Everything's working. Okay, so what is the first test? I guess we should be clear that there is an interface we need to code against. Let's grab that interface. It's right here. And we're just going to put this inside a file called HVAC. Okay, there's our, oops, let's get rid of that. That should TCR, it does. Okay, so our environment controller, or the thermostat, is going to be interacting with a gauge to get the current temperature. And it's then going to be interacting with a blower and a cooler and a heater in order to regulate the environment based on the temperature. So these are nice interfaces here, and we can fake them out. We can pretend like we already have the environment controller hardware and the drivers that implement this interface. So that's going to look like, maybe we'll have a separate file called HVAC test. We only need access to this implementation in test. So let's create, what is this called? It's called HVAC. Let's call it fake HVAC. And we want this to implement the HVAC interface. There we go. We're going to TCR this and just get it all committed, even though it doesn't do anything yet. We also need a fake gauge, and it needs to implement the gauge interface. Okay, and it's very easy. Let's TCR again. It's very easy to implement these. This is going to have a temperature field, and we're just going to deal with it as in integer form. We're not going to do floats or anything like that. And all this needs to do is return the temperature, like that. We'll TCR that. And let's generate a constructor. This constructor does not need to receive anything. It's just going to build the fake for us. let's also generate a constructor for this one. It doesn't need to receive anything. This will have 3 fields. Blowing, cooling, heating. And each of these methods will simply interact with those 3 fields. So setBlower is going to assign the state passed in as the input argument to the corresponding field. As simple as that. This one will adjust the cooling Boolean, and this one will adjust the heating setting, like that. Oh, and I made a mistake. That's wonderful. Missing a return at the end of function. I don't see where that was, but oh, did I do a return? I wonder. This dot blowing equals state. Let's take a smaller step in TCR. Yeah, that worked. Set cooler. So cooling equals state. That was fine. I'm still a little baffled about what went wrong there, but that was a good example of what the TCR tool does when the tests fail. Heating equals state. Great. Here's is blowing. We're just going to return this dot blowing. We'll use these methods in the production code as well as the tests. Return this dot cooling. Return this dot heating. Everything should be fine there. Okay, we've now implemented our fakes, and I think because these methods all kind of look the same and do the same kinds of things, I think they're good candidates for one-liners. Yeah, I like that. This might also be a good candidate, but it's kind of all by itself, so it doesn't make as much sense. My philosophy on one-line methods is that if you have a group of them that all look very similar, and you want to really highlight that, then one-line groupings is a good way to go. Otherwise, I don't do it very much. Okay, what we have now is a fake or a test implementation of the HVAC and gauge interfaces, and I think that's a good spot for a logical commit. We have just wrapped up 16 TCR commits into one single change set, and it's just that much there. Implemented fake HVAC interface contracts. Let's just say implemented HVAC contract. There we go. That's our first logical commit. And now we can get back to thinking about the first test. You know, let's suppose that our fake starts with everything on. So the state of the HVAC is blowing and cooling and heating. And maybe the first test is that when we provide this hardware, this fake hardware, to the controller that we're about to build, that it turns all those things off. That seems reasonable. Maybe, I don't know. I've actually never built a real thermostat. So let's think here. We would want to build our HVAC, new fake HVAC. We would want to build our gauge, new fake gauge, and then we would pass them to the constructor function of a controller, an environment controller. Something like this. So let's create that function. Oh, but we're not going to pass the pointer to the fake. We're just going to pass the interface. So let's make sure we do that. Okay, and then this will return a pointer to a controller. And we'll have this type created. We'll assign the HVAC and the gauge like that, except those fields don't exist. No, and we would run TCR at this point, but that controller variable is not used yet. So we'll just do that little hack so that we can run TCR. I don't want these defined in the test file. They need to be in production, so let's move them there. Okay. Now, what would we do with this controller? We would basically just assert that now the HVAC blowing should be false. So if blowing is not equal to false, or maybe let's just say assert blowing. Oh, and we've got to provide the testing.t, don't we? And maybe we don't even need to assign controller at this point. Yeah, that seems right. We don't need to assign controller. Let's TCR what we've thought about here. Now this little function receives a testing.t and the fake HVAC, and if HVAC dot is blowing, let's say if it's not blowing, oh, you know what? We want to assert that it's not blowing. Hi. If not blowing, that's what we expect, just return. Otherwise, we need to signal to the test framework that blowing when shouldn't be. Okay. And if we were to run this right now, of course it would fail because we have set blowing to true. So let's just say, oh, not return, HVAC.set blower false, and now everything should work. Okay, great. Now we come to a point where I want to introduce this testing with functional options business. We're gonna be writing another function that looks like, assert not cooling. It's going to be very similar. Assert not heating. But I really don't like having to pass t everywhere to do all of that. So we're going to come up with a different way. Let's suppose that we had something that looked like this. Okay, it looks like I'm just repeating myself here, but bear with me. This test doesn't look like much, but when we build the thermostat with its gauge and its HVAC implementations, we just want to make sure that everything is off to begin with. That's what I want this test to look like, and maybe we would even render it as a one-liner. We're going to comment that out, run TCR, and we're going to generate some code here that's going to help us. Okay, so we're halfway there. We now have a test thermostat method that receives a T, and notice we're passing a variadic number of thermostat fixture options. Okay, down here in this code that got generated, there is a thermostat fixture, and notice it embeds a testing.t. It's not strictly necessary that it embed the t, but it's convenient. And there's this other type called a thermostat fixture option. A thermostat fixture option is any function that receives a thermostat fixture and can manipulate it. All right? So we say we want to test the thermostat and pass a bunch of options. We haven't created this option yet, and I don't want to get too far ahead of ourselves. So we're just going to TCR this as it stands. Okay, now let's create the function. Oh, it didn't guess what it was, probably because the code wasn't really compiling. Now it guessed it. Okay, so it assert all off returns a option, which is itself a function that looks like that. So we're basically returning a callback, a function to be invoked later, and later is right here. This is where the options are invoked, and we pass in the same fixture to each one and give them a chance to manipulate it in some way. Now, in order to write this assertion, we need to be able to access the HVAC. So let's create a field called HVAC, and we know what this is. It's a fake HVAC. Looks like that. And so we would want to access these Boolean methods, is blowing, etc. So assert all off if blowing t.error. Oh, and we're just going to say this.error because this embeds the t. Oh no, we're blowing. If we're cooling, oh, well that was thinking ahead a little bit, wasn't it? Maybe we'll just render this as an if statement. If we are cooling, we'll say, oh no, we are cooling. And if we are heating, we'll say that's an error. Now you know as well as I do that all of this is going to fail for several reasons. One, we haven't instantiated the HVAC, so we're really ahead of ourselves. Let's TCR that. Oh, notice we went 2 minutes without running TCR. That's kind of scary. Okay, so we have this HVAC. We want to make sure that it gets created. New fake HVAC. New fake gauge. And then the controller. New controller. We pass it the HVAC. And we pass it the gauge. Okay. And then we assign all of these things. We define them. And that should all TCR. It does. Have you seen this new little feature in GoLand? Put elements on separate lines. Isn't that nice? That will TCR. So this essentially becomes our setup function if you're thinking in terms of XUnit. Okay, and now, you know, if this would no longer panic because of a nil reference, but it will fail to pass, except that it did pass. Why did it pass? That is interesting. When we create a fake HVAC, oh, that's right, because we've already implemented that little logic from later before we started rewriting stuff. Now, if we did this, that would fail. And there you see an example of, oh no, we're cooling, we failed, and it reverted our code. It took away those lines. So let's do the right thing now and set the cooler to false as well. Oh, and that should pass. It does. Last one, set the heater to false, and now everything is off on startup. Maybe we'll name this test accordingly. On startup, everything turned off. TCR that. Okay. The thing I love about TCR is that you don't go very long without running your tests. Notice very few of these go past 20 seconds. All right, but if we don't get going, we're going to pass that again. Okay, so we know how to assert that something is all off. Now, you can imagine that as we go forward, we're going to be doing little variations of these if statements in lots of places. So we're going to have to deal with that and make that nicer. But what's the next test? We know from the spec that, let's see, we're trying to regulate the environment within 5 degrees of 70 degrees Fahrenheit. So let's say that it got colder, too cold. It was like 64 degrees, which is 6 degrees below 70. Yeah. Test thermostat when too cold, blower and heater engage. there's a test. All right, and it doesn't do anything yet, but we'll TCR it. Oh, in fact, let's get rid of that for a second. Run TCR. This is actually a good commit point, a logical commit point. So let's squash all of our TCRs and just consider what we've done. We've written a complete test. We've implemented a functional options fixture, and the production code turns everything off. Okay, on startup, everything turned off. There's it. There's our little commit. Okay, where are we? Now let's bring that back. TCR to back where we were. Okay, we're ready. We're going to be testing the thermostat, and we'd like to make it too cold, and then assert that we are heating and blowing. Yeah, let's try that. Okay, make it too cold. What does that need to do? Well, the gauge would need to report a temperature that is below the 5-degree threshold. So 70 degrees minus 5 minus 1. That's essentially what too cold means. All right. Assert heating. What would this need to do? Well, it would need to do something like that, but the inverse of it. If not heating, we'd say, oh, we're not heating. Assert blowing would be very similar. We would simply say, if not blowing, we'd say not blowing. Now, this is going to fail. So we're just going to cheat for a moment and comment out these assertions. Okay, the code is committed. We can come back and make it work in just a second. Okay, so but the question we haven't answered is, like, how do we invoke the controller? Because the controller has to ask the gauge for the correct temperature, for the current temperature, and then act accordingly. If it's too cold, we turn on the blower and the heater. Maybe we call a method in here that says this.controller. What does the controller do? Well, it's controlling or regulating the environment. So let's say controller.regulate. Okay. That's fine, and it should TCR, even though it doesn't really do anything. So when we regulate, we ask, hey, what is the current temperature from the gauge? And if that temperature is less than 70 minus 5, because that's our ideal minus our threshold, or our tolerance, in that case, we would want to say this.hvac.set blower to true. We're always blowing when we're heating. And set heater to true. Like that. And I believe that is the logic that allows us to perform these assertions. Let's TCR all of that. And we were successful in that attempt. Okay, so a lot has happened at this point. We know how to make the environment feel too cold to the controller, and we can assert that we are blowing, we can assert that we are heating, and from before we can assert that everything is off. In retrospect, maybe these should have been their own little, assert not blowing and assert not cooling, and assert not heating. I still feel like there's work to be done on these assertions. We can make them better. But let's just hold off on that. We're at another logical commit point, so let's wrap up those TCR commits and say when too cold, blower and heater engaged. We got everything, right? Yeah, there's everything. Commit. Wonderful. What's the next test? When too hot, the blower and cooler are engaged. It's going to look very similar, won't it? But instead of being too cold, it's going to be too hot. Instead of heating, we're going to be cooling. All right, so to make it too hot, we first tell the gauge to give back a temperature that is 6 degrees higher than 70. Oh, and we need to then jump start the controller. Regulate. And we want to assert that we are cooling, which means, let's see, assert heat. If not, HVAC is cooling. All right. And this is close to passing, but we need to say else if temperature is greater than 70 plus 5, we set the blower to true, and we set the cooler to true. And I believe that should pass. It does. All right, this is in the wrong spot. Let's put it with the other assertions. Yeah, blowing, cooling, heating. Make it too cold, make it too hot. Yeah, those are all good. TCR that reordering. And we're at another logical commit point. Let's see. When too hot, blower and cooler engaged. Excellent. All right, at this point, I kind of think we're ready to deal with these assertions. What if our little HVAC could give us a readout of its current state of those three booleans? It's kind of a trivariate state. There's three things we're looking for. So what if we had a little string method that produced something like maybe blowing, heating, cooling. So what I'm imagining is all uppercase, all caps means it's on, lowercase means it's off. So in this representation, the blower would be engaged, the heater is not, but the cooler is. So we are blowing, not heating, and cooling. Okay, how do we make that happen? Well, if we're blowing, whoops. And you can probably think of lots of different ways we could assemble these strings. If this dot cooling we'll start with this. It's pretty straightforward, even though it's a little tedious. And there's no space at the end of that one. Else result plus equals heating. Okay, so now we should have that that full string. Now how do we plug that in these tests? So cooling would be something like return this.hvac.string, let's see, strings.contains. If the string contains cooling, or maybe let's look a little higher level. Okay, assert all off. We know what that should be. That's asserting on the whole thing. Let's start there. State equals this.hvac.string. If state is equal to blowing, we're not blowing, heating. Oh, that's backwards. It's in alphabetical order. Blowing, cooling, heating. If it's equal to that, we're good. Otherwise, let's say expected blowing, cooling, heating, and the actual, let's see, what would it need to be? Actual is state, right? Would that do it? Let's just see if we can, in fact, let's just skip this for a second. All right, now that it's committed, we won't lose anything. Okay, it's working. Now, if we were to, say, comment out one of these lines, that would cause that assertion to fail, right? It did. Let's see what it looks like. Expected blowing, cooling, heating, actual blowing, cooling, heating. Okay, that's pretty easy to see what was wrong. Okay, so I think we can get rid of these. All right, so now this assertion checks the state of the HVAC a little bit more elegantly. What I'm imagining is maybe a more low-level assertion function. Assert HVAC state, where you give it an expected string, and if the state is equal to the expected string, we're done. Otherwise, we need to log the error. Let's do this. Yeah, turn this into an error F. We give it the expected, and then the actual state. Let's format those all in separate lines. I like that. Okay, here is an assertion function that I believe we can use to our advantage. We'll replace this entire function with assert HVAC state, blowing, cooling, heating. All right, that is what all off looks like. That works. Okay. We can do the same thing with these, but we've gotten a little bit too granular with these. What if assert heating assumed blowing? Okay, so we're gonna, oops, that is not what I wanted to do. We're going to assume that heating means the following. Oh, no, blowing is on, not cooling, heating. All right, let's see if that works. It does. Let's also assume that cooling includes blowing. So we're not going to do that. Cooling is going to be much like heating, where we will return assert HVAC state blowing, cooling, heating. All right, that should work. We're no longer using this assert blowing method. And boy, these got a lot easier. And they look oh so very similar, don't they? Let's make them all one-liners. That's nice. Okay, that didn't add any new functionality. It didn't add any. It didn't really change what we're testing. It just looks different now. It looks better. Let's make that into a logical commit. That was 9 commits. Cool. Okay. I'm not a big fan of what it did there. We must have pulled in another import at some point. I don't think we should need any other imports. So let's add that to the mix. Okay, the test got a little simpler to read, and the assertions are now a little more straightforward. We just had to implement this string method here. And we might come back and refactor that. Okay, reworked assertions. Very nice. All right, so when it's too cold, the blower and the heater kick on. When it's too hot, the blower and the cooler kick on. What about when it's just right? When comfy, all off. Does that make us... we don't really have to add any code to this. It's basically the same as the first test, isn't it? So the first test... Well, I guess the first test doesn't call regulate. So let's make it comfy. We don't yet have this logic. Let's just say it equals 70. Okay. So when it's comfy, we want to assert that everything is off. And I think this test actually already passes. We don't have to change any production code. Yes, it does. All right, so while we're here, yeah, that's good. All right, now let's think about what happens when it's too cold, when we start heating. And then imagine the next time we check, maybe 1 minute has gone by. Oh, that's a good idea. Maybe every time regulate is called, a minute goes by. And that's how we track the passage of time. That's good. Then we don't have to worry about, faking time. Okay, so let's compose a test case here. When it's too hot, then too cold, we should be blower and heater should be engaged, but not the cooler. All right, so we're going to make it too hot. Then we're going to make it too cold. And we will assert that we are heating. Yeah. And I believe this is going to fail because let's say we are... Oh, and this is kind of hard to read, isn't it? We should extract some variables or methods or something there to make that easier. Okay, when it's too cold, that's what this says. Ugh, ugly comment. When it's too cold, we turn on the blower and the heater. And then let's suppose we call regulate again, and it's too hot. We're going to keep the blower on. We're going to turn the cooler on, and now everything is on. Cooler, heater, and blower, and that's not what we want. So after it's too hot and the cooler is engaged and we make it too cold, we need to turn the cooler off. Yeah, and I believe that makes this test pass. We can verify that just by commenting this out, and it should uncomment it for us. Yeah, because it requires that. Okay, let's do the inverse. When it's too cold, then too hot, the blower and the cooler, should be engaged. And there's a new feature in the IDE. We can actually just flip these two arguments, make it too cold, make it too hot, and assert that we are cooling. That's nice. This will fail because we've got to turn the heater off. Good. Okay. And we've got these ugly comments, don't we? Let's extract this to something. We've got these magic numbers in here too. Ideal temperature, how about that? Let's convert it to a var. And actually we can make it a const. And let's toss that out of there. Here's another instance of it. That will TCR. We need a const for the allowed tolerance. 5 degrees. That should TCR. So if the temperature is less than the ideal temperature minus the allowed tolerance, what I'm wishing we had is something like this, where we call what do we call this? This dot temperature. And in the case that we are too cold, do something. In the case that we are too hot, do something else. Otherwise, do something else. That's where I'd like to head with this. So, what does that look like? This dot temperature. This needs to return something. Some sort of environment state, or yeah, I'm thinking of just a simple integer that represents too hot, comfy. Yeah, so if, and then we basically move this if statement into here and say return too cold. Oh, I guess we need this as well. And I'm making a huge mess. We're going to see if this passes or not. Else, oh, let's grab this. Else if. Return too hot. Else return comfy. That's nice. And let's just move this logic up. If it's too cold, we do that. If it's too hot, we do that. We don't have a default case yet. We can get rid of all of that. And I think this will actually work. Whew, got lucky. While we're at it, let's put those on their own lines. And maybe we'll move these down. Yeah, that should be good. Okay, so now when it's too cold, we are basically specifying what the state of the system should be in all three cases. Same with too hot. What about when, maybe we should roll that up into a commit. Yeah. What did we do? We, okay, we added some tests. Yeah, okay. And we really, really changed the way the controller works. Okay, so when handle rapidly changing conditions, that's what we're doing there. Okay, what about when it's too cold, then it becomes comfortable? In that case, we want everything to be off. Right, now that's definitely going to fail because we don't have a default case. Everything's going to just stay on. Okay, let's see. We were just too cold. No, is that what we want? You know, I think it'll be simpler to do the too hot than comfy. Yeah. So we were just too hot, so the blower is on and the cooler is on. So we're just going to set blower to off. And we're going to set cooler to off. And I believe that test should pass now. It does. I think for the sake of readability of our tests in the right window, we're going to turn off the verbose printing so that we get to see this little OK right there. That's important to me. All right. When it's too hot, then comfortable, everything should turn off. Now, here's a wrench in the gears. When it's too cold and then comfy, the blower should remain on. So we actually do need like a assert blowing kind of an assertion. Too hot, oh, too cold, then comfy. Then now, why should the blower stay on? Glad you asked. Remember, the heater, whenever the heater and the cooler are on, the blower has to be on with them. The blower must continue to run for 5 minutes after the heater turns off. This is to protect the heat exchanger from accumulating too much heat. Okay. Let's see. Assert blowing is simple. It's going to be like one of these where we're not actually composing our own function. We're just saying assert HVAC state, and it's blowing but not cooling and not heating, just like that. That's what it looks like. Yeah, so when it's too cold then comfy, assert blowing. You know, this is going to be a tall order to make pass right now, so we're not going to do an assertion. We're just going to get this committed, but we know it's not doing the right thing. Yeah, because it fails. Oh, interesting. The heater stayed on and the blower kicked off. And that is because we're not doing anything with the heater in this default case. So, you know, let's do something with that. Set heater false. That will TCR. Nobody's asserting on it. And now this gets a little closer. But it still fails because the blower doesn't remain on. Okay, that's easy to do. Notice, let's see. This is the only place where we're actually turning the blower off. I'd like to extract it to a method that says disengage blower, because there's going to be some logic in here. If HVAC is currently is currently heating, then we want to leave that blower on. We don't want to turn it off. So disengage blower is disobedient in that case. It doesn't do what you think it's going to do. Let's TCR that and uncomment that. And I think it should pass now. It does. But it shouldn't, remain on forever. It should only remain on for 5 cycles, right? So there's 5 cycles. And then if it's still comfy on the 6th cycle, we would want to assert that everything is everything's off, all off. Now, that last one is not going to pass. Oh, neither are the other ones. Right, the blower kicks off like, I'm going to cheat here and bring back that code. The blower kicks off because we're no longer heating. Right, okay. So let's comment all of those because they don't work. what do we need to do here? So when it's heating, when we're currently heating and we don't want to disengage this thing, we need to consult some like counter that's kept track of how many cycles or how many minutes we've been blowing. What does that look like? We need a counter up here, or maybe let's call it a delay. Blower delay. And we're just going to track it in terms of calls to regulate. How many calls has it been? So whenever we engage the heater, we would want to set that timer to 5, or that delay. So let's extract a method here called engage heater. And in that method, we will set the blower delay equal to 5. And that shouldn't mess up any other of our other tests. It doesn't. When we disengage the blower, if we are heating, maybe we don't even need to consult heating. Oh, maybe what we do is we don't need to set it there. We want to set it here. If we're currently heating, set this blower delay to 5. This is always tricky to work out. Let's go back to that. Disengage the blower. If we're down to 0, we can do that instruction, right? But whenever we engage the heater, we set it to 5. So we need something else out here that says if the blower delay is greater than 0, then we decrement. That's what it is, yes. Okay. And that shouldn't offend any of the tests, but I think little by little we'll see that this is working. Oh, we missed something. Maybe we're off by 1. Oh, yeah, I think we are. Yeah, so it's this one right here. Because we're decrementing immediately, we probably need to say +1 there for this to work. Kind of fiddly. And now that works. Okay, so when it's too cold and then it's comfy, the blower remains on for 5 cycles before turning off. All right, we've now implemented this important rule here. Keep the blower on. The other important rule is that the cooler must not be turned on within 3 minutes of being turned off to give the freon time to recondense. That's the idea. I have no idea if these are actually relevant or if these rules are actually if you'd actually have to do this in a real system, but we're going to pretend that we do because it makes for some fun logic. Okay, so I feel like what we've done here is worth a commit. Okay, we've basically made it possible to keep the blower on. Yeah. Manage blower after heating. That's the gist of that. Notice that we've started extracting little methods here. And now we have code at different levels of abstraction in here. And then we've added this decrementing of the timer, the delay. So there's some cleanup work we could do here. There's probably another timer that's going to appear soon. Let's call this decrement timers or delays. Decrement delays. That should pass. This may not be necessary, but we're going to extract a method for each of these. Disengage cooler. What is this? Engage blower. Oh, we already have an engage blower down here. So that would have been a duplicate definition. Let's see, do we have an engage cooler? No, that's good. Do we have a disengage heater? No, that's good. We have a disengage cooler. That's fine. And we have a disengage heater. All the tests still pass. Excellent. Let's collapse all these things and group them. That's nice. Oh, except I'm mixing up the decrement with the disengage. That was not right. Okay, there's all of our little functions, methods, whatever you want to call them. Okay, this is all related to heating the environment. So let's just call it heat. This is relative to cooling the environment. And this is relative to just remaining idle, not doing anything. And maybe we'll group those three together. That should all pass. But this should come first. Okay, there's what everything looks like at this point. When we regulate, we're decrementing delays, we're heating, we're cooling, we're idling, which involves engaging and disengaging various parts of the system. All right. Everything in here looks nice. I'm not too concerned about that. Let's wrap all that up into a few commits. Extracting methods. Okay, next test has to do with that cooler logic. So, cooler's on, that means it must be too hot. Then, if it becomes comfortable or too hot, or no, excuse me, comfortable or too cold, the cooler would kick off. And if it went right back to being too hot, we would have to wait till those 3 minutes are up until we engage the cooler again. Okay, so the test scenario might be something like, let's start with what we have and say when too hot, then comfy, then too hot, the cooler, how do we say this? The cooler only re-engages after delay. Ooh, yeah. When too hot, then comfy, then too hot again. Maybe we say again there. The cooler only re-engages after the delay. Okay, so it's too hot. Then it's comfy. This is no longer the case. Then it's too hot again. Make it too hot. I think it is reasonable for the blower to be on. If anything, it's not bad to have air moving, even if the cooler isn't on. Let's make it too hot here. And let's see, that's the first minute, second minute, third minute. And then at this point, we can say that we're now cooling again. All right, and that's the complete test. Okay, this is not going to fly yet. Let's think about how to make this work. So, when we engage the cooler, we would want to set a timer or a delay. Cooler, oh boy, delay equals 3 + 1. All right, there's our delay. Each time around this regulate loop, we would want to say if the cooler delay is greater than 0, cooler delay minus. And I don't think that should offend anyone. Yeah. Okay, so when we engage the cooler, we make sure that delay is set. We decrement it each time. When the cooler comes off, No, actually. When we disengage the cooler, that's when we want to set the timer. Yeah. And then when we try and engage it again, if the cooler timer, I keep calling it a timer, but it's a delay. If the delay is still greater than 0, we return, or maybe we render it, yeah, that's fine. That's great. If the cooler delay is greater than 0, return. Does that offend anyone? Ooh, it does. When too cold, then too hot, blower and cooler engaged. When it's too cold, the heater kicks on. Then when it's too hot... Okay, so when we engage, when we try and heat, we turn off the cooler. We only want to set that delay if we are currently cooling. Okay, that should be okay. Now we need to restore some of the logic we lost. Okay, when we engage the cooler, we only want to do that if the cooler delay is equal to 0. And we had implemented it the inverse way before, but let's just run with that and see. Okay, so now I think that this test is ready to just work. Oh, it's not. Okay, but that is the right test. It failed because why? Okay, it looks like we've got an off by 1 at some point because the cooler didn't kick on. Maybe the off by 1 is that we don't really need this +1 in the case of cooling. Let's TCR that change and then see if that fixed it. It did. Okay, so interesting that you need the 1 here but not here. I'm sure someone watching this can figure that out. If so, leave a comment and explain what I'm missing there and what I'm not understanding. But this is the specification that we're now abiding by. When it's too cold, the blower stays on. You know, when the heater kicks off, the blower stays on. When the cooler comes off, it won't come on again, even if it's needed, for at least 3 minutes. Okay. How's this all looking? Pretty nice, pretty good. This is good. I really like this. If it's too cold, heat. If it's too hot, cool. Otherwise, just idle. It's very nice. Okay. What tests are we missing? Let's look at our spec and just see. I think we're nearing the end here. Yes, it does those things. Yes, blower remains on. Blower remains on for 5 minutes. Cooler must not turn on for 3 minutes. When it's too hot and then comfy, cooler does not turn back on after the delay if it's not needed. I feel like that would just pass, but let's implement it just to be sure. It's going to look an awful lot like this. Okay, when it's too hot, then comfy, the cooler should remain off. Or maybe too hot, then comfy, then comfy, the cooler stays off. Okay, so too hot, comfy, too hot, comfy. Assert all off, right? Is that the test? Maybe we do that a few times just to verify that it doesn't kick back on. I think that should pass. It does. So too hot, comfy. If it were still too hot, it would kick back on, but it's not. So I think we're okay. Let's stand back and just look at what we've done here. We have all these little helpers that assist us in setting the gauge and regulating and also asserting the state of the HVAC. And we didn't have to mess with this boilerplate much at all once it was established. That's kind of nice. And these tests read really well. It's a matter of preference whether you'd want them rendered that way or not. I kind of like them on one line if they fit. I guess that's a contradiction to what I said earlier about one-line methods. And the production code, it's somewhat long, longer than you might have thought it needed to be, but it manages all the state, and it's very easy to see what's going on at a high level. I suppose we could call the disengage methods if we built this controller beforehand, but that's all right. Okay, let's wrap it all up, and let's see, managing cooler in rapidly changing conditions. This one was all about the, yeah, that's probably a good message. Managing the cooler in rapidly changing conditions. And that is our exercise. I hope you enjoyed this demonstration of TCR and also the Thermostat kata, also testing with functional options. Thanks for joining me. Happy coding.